Hi everybody, this is going to be the fourth lecture about the copy swap, and this time we're going to focus primarily on orientation of objects when you start to do copying. So let's start off with a simple digital asset, the axis. This is one I'm going to give to you so that you can use it as well. The problem is I don't see it over here. Well, I will show you how to install it. So first of all, go to install digital asset library and make sure that you have this viewable. If not, you have to change the operator type manager underneath configuration and switch this on. Use op libraries to find OTLs. So that's what we're going to do. Install digital asset library, and over here I've added under this scope. Doesn't matter where you add it, so I'm going to accept this one. And so now if you go underneath digital assets, you find axis, which gives us just like a simple axis node. You have several settings just to show one of the axes and combinations of axes. Also, you can size parts individually. Alright, so this should give us enough control to have like a clear view of what we're doing. So the idea is that we're going to copy this object onto another object, and we're going to use this to clearly see whether the orientation is properly set. So first of all, let me add a sphere, because we're going to use the points on the sphere, and let me make it a little bit bigger. Well, something like this should be okay, and I'm going to change it into a polygon mesh, or a polygon, better say like that. Right, now adding a copy, and the first thing that we're gonna see is, okay, we have all our axes nicely copied over here. Let me just change this to smooth so we have like a better view. Right, so as we can see, we have some kind of proper alignment, at least for the normals. So the normals are pointing just straight up, and as you can see, for the normals it is using the Z axis. So that's quite important. But now we want to have also control over the y-axis, because what we see right now over here is they are all properly aligned, but there's one part over which we don't have like very good control. They're all aiming over here, and then they're all aiming away from this point and goes around. So it's pretty strange what we see over here. So to control this, let's go into the help file. To control this, there is an attribute that you can add in order to control the up vector. So if we go to not local variables, but if we go further, we'll find over here somewhere there's an up vector. The vector pointed in the up direction. This is a vector that the copy sub reads out also like a second orienting vector. Now this is exactly the same principle that you saw in Maya with the aim constraint. So first of all, the aim is the normal, so it's pointing along the normals, and the second one is an up vector which controls how it rotates, how it indeed rotates around the Z axis. So yeah, we're gonna add first of all our default normals, because as you can see this object has no normals, and so it's going to use just a default setting. Houdini can't render or no other package can render with shading unless you have normals. So it's using the hidden baked in normals. So for now we're going to use the facet like this, and let's pre-compute the normals so you see them appearing right over here. Okay, so still everything is normal. We still have the same issues regarding the y-axis. Now to solve this, we're going to add an attribute. So attribute create, and as the first thing that we're going to do is just to manually set a certain direction. So we do this very simply by adding up as an attribute, so you know it could read it out. And now something also which is very important is it read in the help file the up x, y and z. This means that it is at least existing out of 3 elements, but it's not a float of 3 because that's not going to work. It is a vector, and that's something you can recognize when you see x, y or z as a value. So you will see from the moment now that I'm going to set a value over here, let's say 1, you will see everything jumping upwards. So right now the y-axis, they try to go as high as possible. Now let's make it a little bit more visible. I'm just going to eliminate one of the axes over here so that we only see the y and the z axis. So nicely pointing upwards. So if you want, you can always add a second axis, so it's just merely pointing into a direction. That's nothing more. So if we combine those, you have like other directions as well. Alright, let's continue with this. There are of course all kinds of ways in which you can create abnormals. For example, let's create some kind of a lookat function. And what we're going to do is to make sure that all these objects over here, that they're going to look at a certain point. So let me create an add node. With the add node you can just add very simple points. So over here I'm going to add just 1 point. As you can see, it's right over here in the center. Again, if you have problems having like this large axis being around over here, you can always press D and on this view and look around. It's something you should be able to find yourself, how to clean that up. Right, now that we have this point, what we're going to do is we're going to create normals first so that we can see what's going on, and we will do that by using a point sop. So over here I'm going to use this point sop, and here I'm going to create a normal, add normal. So what I'm going to do right now is reading out the point attribute of add1, and I'm going to read out the position. So add1, now we have to tell which point, so there's only one, so in this case it's one with the index 0, then position, which is with a big P, and then the first element, which is the x value. And I'm going to subtract it of the positions over here. So if you're going to have a look, you can already see some of the normals are already trying to point towards our add point over here. And I'll just copy what I've written over here, make it 1, and make it 2, like this. So what we have right now is a sphere with all its normals pointing just inwards, just towards the little point over here. So if I use a transform node and Oh no, if I use a transform node, you will see nothing's going to happen. And again, I want to show this, that a null node can be very useful, because I'm changing the value over here, but my point swap is always reading out from the add. So if I add a null node right here, then whatever I do above, if I change something or whatever, it doesn't matter anymore. It's always going to read out from the proper element. So null, null, null. Okay, so right now if I start changing the values over here, you see our normals are being adjusted. There's just one little thing that I want to change, except for the height, is the fact that we're going to normalize the length over here. So again, we use a facet node for that. And a facet node has like a lot of useful things. I'm going to create a different separate lecture about the facet node itself. So if you see it over here, make points unit length, you see all the points are set immediately to the proper size. Right, so if we would add this one, what we have right now is that all our normals are pointing into that direction. But that's not what I want. I still want to have the normals following the surface normals. I want still to have these objects following the surface normals, but I want to have these up vectors really pointing at this object. So for that, I'm going to create an attribute transfer. So attribute transfer, or copy, which is better because we have exactly the same object. It goes faster that way. Yeah, again, to make sure, attribute transfer is to transfer attributes between objects which don't have same structure or same number of points, and attribute copy is something that you can do between objects which have equal number of points. So we have this one over here, and let's copy this one right here. There's still one thing that I need to do, is over here I have normal, and if I just connect it right here, and let's say I'm not going to copy the attribute but another attribute, I don't have an up attribute yet, so it's going to complain about it. That's because we just have like two normals. If I create the n, for example, you see it's just copying the normals from this one onto this object. So what we need to do right now is to change the attribute. And we do this by just using the attribute node itself. And it's a very simple, useful tool. It says from what to what that you want to do it. So attribute n is going to become attribute up. So now we have over here a point attribute up, and I'm going to add this to up also, and like that. So we have now normal and up. So if you're going to see what's going to happen right now is that everything is just really looking towards that point. So if I make this editable, and let's make it persistent so you can see it at all times. I'll move this one closer, like over here, and now you can see what's going on. So if I move it around, we have the whole thing just nicely rotating. So you could have like a circular movement for the object moving just around, and it's going to follow at all times. Up, down, doesn't matter. Right, Another one that I want to show you for creating an up vector, for example, would be the polyframe. Polyframe is creating for you like tangents and bitangents. Now let me show this. What is it going to do? So if I, for example, draw a curve, up, 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 something like this, I can make it NURBS and do a resample. Not that many. Something like this. Alright, so if you would use this for a copy, and I'm going to switch this persistent handle off again. We get everything pointing upward, but not following nicely. So what I want to make sure of is that the z-axis is really going to follow the line right here. And for that, a polyframe is very useful. So what we can do in this case is, see, we can't see anything, so it is creating values right here. It's using two edges and creating a attribute tangent u. Something we can see if we again go into the split view. So you see tangent u and z values have been created, but we want to make it visible first. So I'm going to change this one in normal. So just make a big N. And from the moment you do that, he recognizes this as being a proper direction, proper value, or a proper attribute, so you can display it immediately as being a normal. So from the moment on we will connect these ones. You see everything is just following nicely. Now this all works nicely because we have like a very straight curve, but once we start playing around with several heights and so on, see, we'll get probably different things. Indeed, so we have like all kinds of bendings and motions over here. So basically, you know, it's doing, you have to do exactly the same thing. So you could basically copy the attribute over here, throw it in, and now we have like objects following the line and always pointing upwards. So also very useful in lots of cases. So that's for the polyframe. So you can use this on lines, you can also use this just on polys in general. It's a very useful tool which is going to calculate for you each of those corners. And the last thing that I want to show you is, and we're gonna go back to the sphere for that, is that in fact you can control the direction of how these these points are flowing manually by combing all the normals. It's usually something they use for controlling fur, but you can use it for all kinds of things. It's just a paintbrush. So comb, and let's see, let's make this visible, and I'll make it also a little bit more dense so that we have some more points to come. So with shift I'll make it bigger, and then over here with the brush I'll make it so that the radius pressure is lower, so that at all times it's going to keep the usual size more or less. So let's come. I'm going to make this nice curly, or like turning around. And then over here I'm going to the side. So like this. And do make sure that you comb everything, because that's needed for the up vector. And so if the up vector is the same as the normal, it's gonna probably result into something which is not working properly. This is the same with the aim constraint. So if in Maya, if you have like an aim constraint aiming at just exactly the same direction as if your up constraint and your aim constraint or sorry, it's a little bit difficult to do painting and talking about something else at the same time. So what I wanted to say is, if the aim constraint and the aim direction and the up vector are basically in the same direction, it can't resolve it properly, which is logical. You need to have like really some kind of a frame in order to make proper orientation. So okay, we do have this now. If I add it, you'll get as expected. So all the normals are just following this direction, but we want to have the normals facing up again and just use it for the y value. So in this case, same thing. I'm going to use the attribute in which I'm going to control this, so that the normal is becoming the up, and that we're going to attribute copy it. So we're going to do the same. Instead of using this attribute, we're going to use this one and copy it on top. So right now we have the y values following a proper direction. So let's make this more clear, like that. So this is nicely showing how you can control your object's directions for a copy swap. So it's a combination of using the normal and the up vector, and I've just shown you several methods of applying directions. Okay, this concludes it for the copy lecture using for controlling the direction of the copied objects.